And so we're going to spend an hour together here, and I'm going to show you some of the basic functions. We're going to import data. We're going to build a model. We're going to assign the measurements from the data block to the model. We'll talk about issues, and we're going to use quite a few of the ME'scope commands. And then at the end of my talk, we're going to open it up for questions. So you will be able to text your questions to Brian. And when I'm finished, then we will answer each of your questions. So hopefully you'll have some at the end of my presentation. Now you can see this is my desktop, and it's a little bit after 10 o'clock here in California. And so we're going to begin. I've been through my morning coffee, and Brian also. So let's get to work. I'm going to open up ME'scope. I have an icon over here on my desktop, and I'm going to double-click on it. And you can see it's opened up a couple of windows here. Now this first window is because my license is a sales demo license. And so any of our resellers or salesmen would have this window come up with their license, and it gives you a list of all the various options that can be enabled in ME'scope. And up on the top is a list of the packages. Now your package may be an ODS, an ODS Pro, a Modal Pro, whatever. Mine is enabled with all the options, and so it says Visual STN. STN stands for soup to nuts, and I've got everything turned on, but I'm only going to use the basic functions of ME'scope today. So we're going to use, if you just have an ODS package, we're going to use just those commands that you have in your package also. Perhaps next week we'll get into modal. We'll do some curve fitting, and or next week, but next month. And then following that, after we'll get into using SDM and some of the more advanced FEA and advanced analysis capabilities that you can purchase with ME'scope. But today I want to click on OK and go through this window, and now it's going to start up ME'scope and open up the ME'scope window. Okay, here we are in ME'scope, and this is usually the first screen that comes up. We call it our start page, and on the left you can see a list of my recent projects. These are the ones that I had open, that I was working on, and that I saved previously. I can also open any project file that's on my disk, and we denote ME'scope projects with a VTPRJ extension. So that's Vibrant Technology Project. I can create a new project. Over on the right are, again, if you're connected to the internet, some news. Here it's listing the date code of my software. So this software that I'm using was created on January 11th. And then sometimes we'll put some notes in here talking about bug fixes or new installations or new features and so forth. Down on the lower left, again, if you're connected to the internet, is a link to the Vibrant Technology website, and also a link to another website we have called a 3D Model Store. Now out there are many more complicated models than maybe you would ever want to build in ME'scope by yourself. Many of them are free. Some of them we charge a small amount because they've been put up for sale by other ME'scope users who have built those models, and they offer them for sale for you also. So you can import those models into ME'scope and animate your data with them. I'm going to go ahead and open up this project right here called Tutorial Number 1, ODS Animation. This is the one that I had open the last time I used ME'scope. Now it's going to open up this project for me, and let me just explain to you a little bit more about projects. And you can see that I've got a toolbar up here, and I've got some tools. I've got a menu bar. I've got some tabs. So your ME'scope will come up like this, but maybe you've got some different tabs. As I move my mouse pointer onto a tab, it's showing me some graphics of each of the projects associated with that particular folder on disk. And let me just go show you how we can access that information. I'm going to pull this down here. I've now put my mouse pointer over the project tab, and it's showing me the contents of the ME'scope project that I just opened. And you can see where it's located on disk. It's under ME'scopeVES, tutorials, and then it's the name of the project and a description. This project has 2 data files in it. It has a STR, or a structure file. That's where we build a 3D model, and then we animate shape data on that model. It also has a data block. And here's, as I put the mouse on that name of that file, it shows me a small picture of what you can actually see when the window is open. And that data block has some FRFs in it. And we're going to talk about those in a minute. But let me show you what's over here on the right, or explain to you. This is like a Windows Explorer list of my disk, and I want to focus on the folder called ME'scopeVES. So this is under My Documents, ME'scopeVES. All the way to the top here. Here's ME'scope. You can see I've got a lot of folders on my disk under My Documents. And I come all the way down here, and here's ME'scope. And these folders are the ones that are going to contain my ME'scope projects. Now, some of them are red, and those are the ones that I have made into tabs so that I can simply click, for instance, application notes. If I go over here, those are all the projects that I have in that folder under application notes. And if I go back to the project tab, you can see that there's some other ones, demos and machinery. And the way you make one, let me pin this open for a second here so we can look at it. There's a little pin over here that I pinned it open with. If I right-click on one of these, for instance, if I want to put aircraft up there as one of my tabs, I'll right-click on it with the mouse, and another little menu pops up here that says Show Folder as Tab. So if I click on that, now aircraft is up here as a tab, and all of my aircraft projects are going to show up on that tab, or in the panel that's underneath of that tab. So I'll go and take that one back down. Now if I click away, you can see that it's turned red now, because that folder is now a tab in ME'scope. So this way you can keep track of all your projects. You're going to forget where you put things, but if you put them on tabs, then they're going to be easy to find in the future. You can see that it's checked as the Show Folders tab. I'll execute it again, and it removed that tab from the list on the toolbar there. Okay, I'm going to go and unpin this, and when I do that, it will remove the panel that's under my project. Now the project tab is always going to show up. A project, as I said, is a collection where it's got different types. There's structures, there's data blocks, there's shape tables, acquisition windows, reports, programs, and added files. So I can really add any data file into ME'scope. Now all of these other ones, the structures through the programs, that data is actually saved in the project file on disk. So you won't lose any of it. It's all kept in one place, and that's a Microsoft SQL file that's all saved in one disk file. The added files, ME'scope just saves a link or a pointer to that file on disk. So I can have Word files, I can have Excel files, I can have movie files, sound files, whatever, and I can add those to my project. And if I open one of those, it will open up in its own application outside of ME'scope. All these other ones are going to open up in a window inside of ME'scope. So I've got right now in this project, I've got 2 data files, one with a structure model in it, and one with some so-called FRFs. So let's go look at the data first, and then we'll talk about the model. And one of the other things that I want to point out to you is how to work with these windows. There's a couple of commands I'm going to use quite a bit up here. One of them is called Arrange Windows for animation. The other one's called just Arrange Windows, Tile the Windows. So let me just click on that one, and you can see that kind of move things around, but this window here is too big, so I'm going to slide this one over. And the way both of these commands work is the last window that I clicked on, we call that the active window. That window will maintain its current size when I execute one of these commands up here. So if I do arrange windows, that way I can see two windows at once, and I'm using up all of the available real estate on my screen to maximize the size of those windows. Now another thing to point out, and these are used quite a bit, is this command over here. It says display objects spreadsheet. Now, the tooltip that I'm seeing up here is actually telling me where that command is located in my command menu. For instance, if I want to find this window, arrange windows for animation, I just go over here under my Windows menu, arrange windows, and there it is for animation. So most of the commands in ME'scope, there's a few exceptions, but most of them are in menus. And when I click on a particular window, its menu bar and its tools, its toolbar, and these are just little icons for some of the commands. You can add any ones that you like to the toolbar or take them off. But these are the ones that we ship with the software that are up here as the popular commands. Now this one over here, let's go back to this one because it says display object spreadsheet, and you can see the little arrow is pointing to the right. If I clicked on that, it just did something in the window. You can see the window is divided between graphics on the left, a spreadsheet on the right. And so when I click on that button, it hides the spreadsheet. Now the arrow is pointing in the other direction. If I click on it again, it brings the spreadsheet back. Same thing over here now. If I click in this window, the data block window, now if I click on that button, it shows me the spreadsheet. So it's the same format. It's got graphics on the left, spreadsheet on the right. This one's called a traces spreadsheet. This one over here is called an object spreadsheet, and you can see the first column here says select substructure. So we're going to get into what that all means in a minute. But let me just click back and hide these two. And so the next thing that you may have noticed as I click into this window, the toolbar changes to all the commands that are available in this window. If I click over here in this window, I got a new set of menus and tools for the data block window, back and forth. Now that's a new feature in ME'scope that has just been put in recently. You may be used to having all of the commands in the window itself, and that is still available. Let me show you where that is. If I go over here under Window, Project, my project command, and I go down here under ME'scope Options. Here is a pick list in here that says Menu Style. And now we've got 3 different styles for the menus. We can have multiple menus, and that's what perhaps you're used to, where each window has its own menu of commands. I've got mine set on single menu, and you can also use a ribbon, which is a more recent Microsoft paradigm for displaying your commands on a toolbar, but it's called a ribbon now. I'm going to just set mine back. Now if you change it, it wants to restart ME'scope to make the change. I'm just going to ignore that because I don't want to make the change. Okay, let's go over here, and another feature that's fairly recent in ME'scope is floating menus. So I'm bringing these menus up by right-clicking in the window. Now this is a different set of menus that are commonly used when we're working in a window. So here I am over in the data block, and you can see that there's an edit menu, a display, a format, and a tools menu. Well, those are the same edit, display, format, and tools that appear up here in the menu bar, in the ME'scope menu bar. But it's a little more convenient to execute commands by just right-clicking in the window itself. And the first command in each of these menus is center the data block window. So that's going to make it large. And now I can look at this data, and I may want to bring the spreadsheet out here. I can also just drag this splitter bar. So I can put this, I can split the screen here any way I like. between the spreadsheet and the graphics. Let's look at some of the property measurements in this data block. There are 30 of them, so the first column in the spreadsheet is the measurement number. Now that's very important. You want to keep that in mind. We're going to come back to that later, because the measurement number is the way that we tell ME'scope how to animate shape data out of this data block. The second column is, do I want to make the trace visible? See, you can, these measurements are also called traces. Now the trace refers more to the graphic, but it's also called a measurement. Each row in this spreadsheet is a different measurement. Then we have DOFs. Then we have units. Then we have measurement type and color and input-output. Now there are many more columns to this traces spreadsheet, but these are the important ones. So let's just talk about the DOS column. Is how these measurements have been labeled by me so that I can tell where the measurements were made on the structure. So the first DOF, you can see that each of these DOS contains a point number, a number, and a direction. So the first one says 1Z, there's a colon in the middle, and a 1Z. I'm going to hold down the Control key and spin the mouse wheel, and you can see that it makes it a little larger. This feature is in all the spreadsheets, so if you're getting a little old like I am and your eyesight's going bad, then you can hold down the Control key, spin the mouse wheel, and the spreadsheet will get larger. Now you can clearly see the DOS for these 30 measurements, and as I scroll this scroll bar here and look through these, you can see that there are 2 points and directions, a point number and a direction. The first one we call the roving DOF because it's changing. So that was the transducer or the sensor on the structure that was changing from point to point. And we made these measurements at 30 different points, and the first DOF is always the one that changes because that's how we're going to get shapes from our data. The second one is always behind the colon, and that's called the reference DOF, and that one is fixed. That one doesn't move. So you can see that the reference when we took this data was at 0.1 in the Z. So those are point numbers and directions, which we call a degree of freedom or a DOF. The next column are units. This gives me a little more clue of how this data was measured because it says G's divided by pounds of force, or G's over pounds. That means that the numerator of these were units of acceleration, and the denominator is force, pounds of force, English units. Again, I can change these units. If I click on this pick list, there's a whole bunch of different units I can use in ME'scope. And in fact, I can simply type in, this is a text field, I can type any units that I like. But these measurements were made with an accelerometer, so that's why we have units of G's. And, well, I'll just tell you, in this case, we use an impact hammer to test this aluminum plate. So the aluminum plate over here is actually a real structure that we tested, and it's got 30 points on it. Let me display the point numbers so you can see there's a grid of 5 by 6 points. So I have a point on this model for every measurement. Let me go back to the measurements and let's look at them some more. Now, this is a little bit of a strange format here, so I'm going to change my format to a row column format. And there I'm just looking at the imaginary part of one of my traces. Let's go to and display the magnitude of it. Okay, this is a common way that we look at this type of data with a log magnitude because we're looking for peaks in this data. What are the peaks associated with? In this particular type of measurement, which we call a frequency response function or an FRF, every peak in the data is evidence of a resonance or a mode of vibration or a natural frequency. All these terms apply to the resonant behavior of the structure. So normally when we're looking at vibration data, we want to know, are there resonances being excited? This type of measurement will isolate those as peaks in the data. That's why we make this type of a measurement. An FRF always has units of response divided by force. So it's either going to be acceleration, velocity, or displacement divided by force. I may not be able to measure the force, so then I would make a different type of a measurement. Maybe I make a ratio, I form these as a ratio of G's over a reference accelerometer. Well, then I would call that a transmissibility. That's a different type of measurement. But an FRF is, in this case, G's divided by force. Now, another characterization of our measurements is the input and output characterization. And here we have just 4 different choices. You can think of a structure like a black box. We're going to apply some force to it. That's the input. And we're going to measure the response or the output. So the measurement in this case is what we call a cross measurement. It is a measurement that's describing the dynamics between an input force and an output acceleration. But I could also have measurements in ME'scope that are just outputs or just inputs or both. In this case, this is called a cross measurement because it's between 2 degrees of freedom. That's what we have over here, 2 points and directions. And it's an FRF with units of response divided by input force. So these are very special. Let's go ahead now and I'm going to put this back down, and we've got a model here so we can look at this data in animation. Let me slide this back over here. And now I can start the animation from either window. I'm going to start it over here in the draw window. And you can see that right now I'm in the drawing state. The structure window is either in the drawing state or the animation state. That's all I can do in a structure window. I can either draw the model or I can animate it with some shape data. So I'm going to go ahead and start the animation. And now it's animating. Well, what is it animating? First, if you look up here in the toolbar, there's a list, and my 30 FRFs data block is listed in here. This is called an animation source list. So if I look at this list, you can see there's only one animation source available, and then there's a choice of none. So I can do some animation in here without any data. But in this case, I'm animating from the data block with the 30 FRS in it. So that's over here. And as I move the cursor, what I'm displaying is the data for these 30 measurements all at the cursor location. So the first thing I want to do with any set of data, once I get it into ME'scope, I want to go down here by these low frequencies and see if I have a consistent set of data. Let me turn off the point labels here so we can see it a little better. But that is characteristic of this data because it was, when we tested this aluminum plate, we put it on some foam rubber, and that is what we call a rigid body mode. That's just the plate bouncing up and down on the foam rubber as we impact it with a hammer. That's what we expect to see at these low frequencies down near what we call DC. DC is direct current or 0 frequency. So there is the cursor at 0 frequency, and you can see it's still kind of bouncing up and down as a rigid motion on the foam rubber, and there's a little bit of error in the shape there. But that's because at 0 frequency, the accelerometer doesn't respond very well. The piezoelectric accelerometers that we use go down close to 0 frequency, but they don't actually measure right at 0 frequency, typically. Now, there's many different types of accelerometers. Some of them will measure DC motion. In this case, the one we used had a little bit of error in it, but that's still an indication that I've got good data. There's 30 measurements, all animating. These are independent measurements over here. And when I put them on this model and look at my vibrations spatially, that's an indication that I've got good measurements. Now, if I took some bad measurements, or if I had some sign reversal, if I had to maybe impact from the bottom of the structure, then that point would be moving out of phase, or it would be wildly moving differently than the other points. So that's the first thing I want to do with the data, is make sure that I've got a good data set here. Now we're going to go out and put the data close to one of these peaks. There is a mode of vibration. Now, how do I know that? Well, it's it's still an ODS. Technically speaking, I'm just displaying the data that I measured. It's a deflection shape of the structure at that frequency, but it's being dominated by a resonance. And that's the type of mode shape that I expect to see at the low frequencies in any structure. I don't care whether it's a car body, an airplane fuselage, a machine tool, a washing machine, a guitar, whatever it is I'm testing. I expect to see what I would call first torsion. So that's a twisting mode or a torsional mode, a very simple waveform. And because this was tested in what we call a free condition, that is, the boundaries or the edges of it are not being clamped or held down by any stiff boundary condition, that's a free torsional mode. That's what I expect to see on a structure like this. But I'll see one in a car body or an airplane fuselage very similar if I test it in a semi-free condition like this. Now, if it was mounted to a wall, or if this was a piping system and I had it rigidly mounted to a wall in certain places, the mode shape would look a little different. But I would still see a very simple waveform which I can recognize and give a name to it called first torsion. Now let's go to this next peak. That mode shape is bending of the structure. I call that first bending. Now the reason we use the name first is that as I go up here from the low frequencies where there's no bending or torsion going on and I get to the first peak, I see what's called a flexible mode, a flexible body mode. The structure is actually deforming. And then I get up here and it's actually bending. And that's what we call first bending. I expect to see that in my data no matter what I've tested. And in my experience, I've always found something that I could call first bending or first torsion. Now let's go up here to the next frequency. And there is another bending mode. Again, it's first bending, but it's in the stiff direction. In other words, this, geometrically speaking, this plate is longer than it is wider. And so you'd expect it to bend in the long dimension first because it's weaker in a longer dimension than it is in a shorter dimension where it's a little stiffer. But the mode shape looks the same. It's what we call first bending in the stiff direction. Still a very simple waveform. The next mode is a double twist. So we call that one second torsion. That's a twisting mode, but it's more complicated than the first torsion at the lower frequency, which is just one twist of the structure. Up here, the structure is twisting essentially twice. Let's go back here to that peak. And then the final mode up here is a mode that I can't really give a name to, maybe second bending, but we run out of names for the mode shapes. We can always use their frequency, their modal frequency, their natural frequency, and that's what's listed up here on the screen at 972 hertz. I can always refer to that mode as a 972 hertz mode, regardless of what its mode shape looks like. The simple modes, the low frequencies, I can give them a name. The higher frequencies, I identify them by their frequency. And that frequency and that mode shape will not change. Now, many people get confused about this because they excite the structure from one point and they get an ODS that looks different than when they excite it from a different point. That's an ODS. That's a deflection shape. That's a function of where the force is being applied. Mode shapes are not a function of where the force is being applied. They are a function of the structure itself, a property of the structure. So unless I change the mass, the stiffness, the damping of the structure, or I change its boundary conditions, in other words, I clamp it down on one side or attach it to something that's very stiff, the mode shape will not change. It doesn't matter how I take the data, the mode shapes are going to be the same unless something physically changes. So keep that in mind. That's a little exercise in modal. We've got some data here. Now what I want to do is start over, and we're going to recreate this whole project from scratch. We'll import these measurements. We'll build this model. We'll set up the animation and use more commands in ME'scope to do all that. So I'm going to go up here and under the project menu, I'm going to say I want to start a new project. So it says, do you want to save this project? And I'll say no, because I've already got it saved under the tutorial section of the tutorial folder on my disk, and I don't want to change anything. Now it's asking me where I want to store this new project. So the first thing I have to do to get started is create a file, a VTPRJ file, somewhere on my disk, so that when I hit the save button, it will go back into that file. Now this new project is called new project number 1. That's a good enough name, and it's going to store it on in my ME'scopeVES folder, which is a good place to find things. I'm going to go ahead and say yes, or save it. And now I've got a new project. If I go over to my project tab here, there's my new project. There's where it's located on my disk, ME'scopeVES, new project, under my documents. I may want to rename this now, so I'm going to right-click on it, and it says file name and description is one of the commands. And I get a little dialog here that now I can type in a new name. So I'm going to call it my first project. I'll give it a new name. And now the name on disk has been changed, and if I put the mouse up here, I can see that it's called myfirstproject.vtprj. And there's no files in it. It's empty. I'm going to go up here, and the first thing we typically would do is import some data into ME'scope. So I'm going to import a data block. I can import structure models, shape tables. I can add a file. I can import an older ME'scope project. We've been in business for 20 years, so some of our projects, maybe yours, are very old, and that will convert them to our new ME'scope format. Okay, so now this is a file dialog box, and it's looking out on the disk for me. And down here in the lower right-hand corner is a pick list of filters or file types. So here is a list of all the different types of files that you can import into ME'scope, different file formats. And most of these have a name. They're the analyzer manufacturer. And then the universal file, which we're going to use down here, is a very common file format which many of the analyzers and data acquisition systems can save data in. So I'm going to select that one as the filter or the file format that I'm looking for. And you can see that it's looking for a number of file name extensions, but the most common one is the UFF, .UFF. Now, the data that I want to import is under my tutorials folder. So I'm going to double-click on the tutorials folder, and here is a file with 30 FRFs in it. Plate 30 FRS UFF. That's the one I want to import. I'm going to import that, and it's done it. And now there is a spreadsheet very similar to the one we saw in the data block window itself. It's got select trace here. It's got my measurement numbers, 1 through 30. It's got all of the same information that we reviewed in the data block when we opened up that other tutorial project. I can edit the data here, or I can simply go ahead and import it. Now it's asking me if I want to rename this to a different name, this data block file. I'll just take the name of the file that I imported. And here it is. Here's the window. Let me make this large. And here's the same data that we were looking at before. I just imported it from a UFF file. Now I may want to change the name of this. Over here I can do the same thing that we did with the project. If I right-click, file name and description, I can name it something different if I like. But I'll just stick with the name that it gave it, Plate 30 UFFs. Okay, so in order to animate this data, we need to build a model that looks something like the test article. Well, in order to do that, I'm going to go up here under File again and create a new structure window. So this is new. Before we used the import command for the data block, now we're going to use the new command and open up a structure window. And it wants to name it. I'll just call it Structure 1. Again, I can rename it later if I want to. And it's an empty window. No graphics on the left and nothing in this spreadsheet over here on the right. Now we're going to use one of the drawing tools in ME'scope. Let me just right-click here, and we can look again through some of these menus, and you can see that a lot of them are talking about objects, a lot of these commands. So what do we mean by an object? Well, in the drawing, objects that we can have in a structure window are listed right here: points, lines, surface triangles, surface quads, substructures, and then a number of FEA or finite element objects that we can put on this 3D model if we're doing FEA work or SDM work. Now, a substructure is merely a collection of points, lines, and surfaces. A triangle surface is between 3 points. A quad surface is between 4 points. A line is between 2 points. And then the very basic model that we would build has to have some points in it. So I've got to create some points in my drawing before I can add any of these other objects. But we're going to go use a different tool that will create substructures for us that already have points, lines, and surfaces in them. So how do we do that? Well, let's go down here under the Draw menu. Again, the Draw menu is the same as this one up here, but I'm going to take it off of the right-click menu, and down here under the Draw menu is something called the Drawing Assistant. So I'm going to open that, and you can see the drawing window changed now, and over on the right I have a tab that says Substructure. So what this Drawing Assistant allows us to do is build models by manipulating substructures. And this is a list of them. This is called a substructure library, or a browser of what's in my library. And as I scroll down here, let me just make this a little larger so you can see. There's a whole bunch of substructures in here, different geometric shapes. And then as I scroll down, they get more complicated, and some of them are, there's a whole car body, and so forth. So my substructure library has a lot of different substructures in it, which I can use. These are models that I have previously built or that were installed on your ME'scope version, and you can add your own once you've built a model, so you don't ever lose your work. You can always go back and use it over again and modify it and use it for a different machine or different structure that you're going to be testing. Now, these ones up on the top are called editable substructures. And we're going to, and what by that, it means that I can actually change the number of points and the dimensions of them so that they more closely approximate the test article. I'm going to grab one here called an editable plate because we tested a plate, and I'm going to start off with this plate. Now, this plate here, you can see now I have a substructure called an editable plate in my spreadsheet down here. It's got 4 points in it. It's got 4 lines, the 4 corners, the 4 lines, and it's got a surface, or at least one, maybe more, I don't know. But it's already created this for me. Now you can see that I've got a spreadsheet called Dimensions. I've got a tab called Position, and I can extrude or revolve this substructure and make it into a 3D substructure. Right now it's kind of a 2D. It's just a flat plate. But that's good enough for this model that we tested, this aluminum plate, to look at our shapes. We could come back and draw a 3D plate here very easily and animate that also. Today we're just going to start with a 2D plate. Now, I go in here, I want to change some of the properties of this plate. You can see I've got a parameter here, a value, and units. Now, what about units? You can see these units are meters. The M is for meters, and where did that come from? Well, I need to change the units if I want to make this thing dimensionally correct. But let me just say, in order to animate shapes, I don't need a model that's dimensionally correct. I just need one that is proportionally correct. And by that I mean the width and the length of it have to be approximately, with respect to one another, the sizes of the structure that I actually tested, so that when I look at the shapes, they are going to look like the shapes that came off of the real test article. But anyway, let's go look at the units here for a minute. In order to change units in this window, I do that in the options box. If I go to structure options, now every window has an options box. And that's kind of like your dresser drawer in your bedroom where you just throw all your extra stuff that you don't know where to put. The options box in ME'scope are like that. So if you're looking for something and you can't find it in a menu, then it's always good to go look in the options box. And you can see this options box has lots of different things in it. But here is a tab called Units. And in here are mass units, force units, length units. And you can see my length units are set to meters. I got centimeters, millimeters, and some English units. If I'm just drawing a structure, I don't need to worry about force or mass. These are more important if I'm doing FEA work or SDM modeling work, simulation work, other things. So I may want to set those up, but I don't need to if I just am going to animate some ODS data from some measurements like we're doing here. So let's just leave them alone as meters. And I'm going to go in here now, and I want to add some more points to this and make a grid of 30 points. So I'm going to go here and type in a width of 5, and I'm going to go 5 points in that direction, and I'm going to do a height of 6, and I'll go 6 points in that direction. So now I have a grid of points of 30 points, 5 by 6. So that's roughly the dimensions of the plate that I actually tested. But it's a vertical plate. So I'm going to go over here to the Positions tab, and I'm going to change it. You can see I can do two things here. I can rotate it, and I can change its origin. I can translate it. I can move it up and down or sideways. And these controls are allowing me to do things in the X, Y, and Z direction. And you can see I've got global selected here. So what do I mean by global X, Y, and Z? That's this little axis right down here. This is global X, Y, and Z in the lower right-hand corner. And you can see that Z is pointing vertical and X and Y are horizontal. If I want to rotate this from a vertical to a horizontal plate, then I want to rotate around the Y direction. So I'm going to go up here and click on the Y, and every time I click on one of these arrows here, it's going to start rotating the plate. And how much is it rotating? Well, right up here it says 10 degrees. So every time I click, it's going to rotate it by 10 degrees. And if I click on that 9 times, it's going to rotate it by 90 degrees. And now I have a horizontal plate. I could change that if I want to go faster. Let's hit the reset. It'll put it back to where it started. And if I put in a 45 degrees here, and now I touch the button, let me touch the up arrow. We'll rotate it. See, I just needed to touch it twice, and it made a horizontal plate for me. So I'm done with the model. I have the geometry that I want. So I'm going to turn off the drawing assistant, which simply will remove those tabs. Now I get a message that says, warning, the selected substructure will no longer be an editable substructure. Do you want to continue? So you don't want to leave the drawing assistant if you still want to change the number of points and the dimensions as we were doing here. But we're done with it, so I'm going to just say continue. And I can come back into the drawing assistant, and we'll see what it's changed to. And I want to select that substructure. Now in the Dimensions tab, all I can do is resize it. But if I turn this lock the aspect ratio off, then I can reshape it also. So I can still change the dimensions. And here I've got meters, again, as units. So I can actually type in a number here if I want this thing to be a different number of meters in the X or the Y direction. I can do that. And I can make it geometrically correct. I can still rotate it, and I can still extrude it or revolve it. But I cannot add more points to it with the drawing assistant because it's no longer an editable substructure. Anyway, we're done with that, so let's go out of this. Now the next thing we need to do is number these points, because what I want to do is match up the DOFs over here in my traces spreadsheet that are telling me where these measurements were made and what direction. I want to match those up with the DOS on the model. So the first thing we're going to do is number points. You go under Draw again, under Points, and number the points. Okay, I have a little box up here Let me make the graphics a little larger so we can see everything. And this little box says, click near a point to number it. Next point number is going to be number 1. So let me go ahead and do that. Now, if I hadn't built this model before I took the data, I may not remember exactly which point is number 2. Is it here or is it over here? Well, let's just take a guess. I don't know whether this is right or not, but let's just say I forgot how to do the numbering. And so this is where it's a good idea, before you take a lot of data on a structure, that you build the model first, number the points, and then use that model, or just copy it onto a clipboard and have a picture of it, print it out on your printer, and so when you go to take the data, you know where these measurements, what numbers they are. But I can't remember. I didn't keep good records. All I know is that I've got 30 measurements taken from points 1 through 30 in the z direction. So I've got them numbered here, and I'm done. What about the z direction? Well, that is in another place, and I need to go down here because we're going to create animation equations. And we're going to do that by assigning measurements from the data block to points and directions on the model. So let me open up the equation editor. We don't have any equations yet, but I need to define not only the points, but the direction of measurement in which I took this data. Now you can see that each of the points now has a little axis displayed by it, and because they're all selected, I'm seeing the axis for all the points, and z is pointing up, which is the way the structure was impacted, or I could make it all point down if I wanted to be correct, but as long as I'm consistent with the direction, pointing up is going to be fine. If I click over here on animation equations, you can see that there are none. This is empty here. This is empty. Let me unselect, and I did that by simply clicking near a point. And what I'm using here is another feature in ME'scope called Click Select. So if you look up here on the toolbar, there's a command here called Click Select. It's under the Edit menu, Click Select, and that was turned on automatically when I came into the equation editor. And every time I click near a point, it's going to select that point and then display its equation for me over here. But we don't have any equations yet, so let's go make some equations, and then we'll take a look at them and see what they are. We're satisfied that we got the points numbered and we got the directions correct, so we should be able to make or create the equations now. I'm going to come down here under Animate Equations, Create Equations. Okay, here it's saying, warning, the following objects are selected. You want to unselect them. See, I have 1 point selected over here. And one of the rules in ME'scope is if I select objects or if I select traces, then the operation only occurs on those selected items. If I unselect them, then the operation applies to all of the items, in this case all the points. So I want to unselect them, and it says I've created number of measured animation equations, created 30 of them. That's what I expected. I've got 30 measurements. I assigned all 30 measurements to a point in a direction on the model. So if I go back here now and click on point number 1, there you can see it's got an equation in there, and it's going to animate this point in the z direction with measurement number 1 from the data block. Now another thing to explain here is that point number 1 is also the first row in my spreadsheet down here of points. So I've got a spreadsheet full of coordinates and other properties of my points, and you've got a label here. See, when I numbered the points, it went into the label for that point. But let's click on point number 2. If I click on that one, I can do it here in the spreadsheet, or I could have clicked over here, and you can see now I've got point 2 selected also. Point 2 in the spreadsheet, I actually numbered that as point number 12. So that's going to animate with measurement number 12. Because remember, the DOF for measurement number 12 was 12 in the Z. And that might be right, it might not be right, I don't know. The only way I'm going to tell is to go start the animation and take a look at my shapes. Well, there it is. That's pretty ugly. I did something wrong. Let me draw this over here. Now you see how the data block ended up over here on the left and the animation on the right. Another property of these arrange commands is that they look at the upper left-hand corner. So all I need to do to arrange things the way we had them before is to move the upper left-hand corner of my windows so that they're in the order that I want them. And then when I hit the arrange, it will put them back the way we've been looking at them. But that's a pretty ugly looking ODS. Let me go down here by DC. I expect to see the rigid body motion of the structure because I tested it on a soft suspension. I don't see it. So I have obviously numbered things the wrong way here. But I had some choices. I could have numbered in this direction, and then depending on where I restart, come up with a different point numbering scheme. So let's stop the animation. I'm going to go back to drawing. Let's make this large so we can see. I'm going to go to draw points, number the points. Now here I can either clear all these labels or I can just start numbering again. But I want to start from 1, so I'm going to put a 1 in there. And I'm going to start back here at 1, 2, 3, 4, 5. Now I could go this way or I could go this way. I'm not sure which is right, but let me just take a guess. And I'll go this way and keep numbering. Or if that's confusing, let's just clear them all and start with a clean slate. I'm going to go back here and put a 1 in and start back here at point 1 and number this way. Now I could just go into the spreadsheet, the point spreadsheet, and type in labels also. So that's the way I could create equations, by just typing into the spreadsheet. But this is a little bit faster and it's graphical and I can make sure that I get everything numbered correctly. Now if I make a mistake, let's just say I numbered that guy there and I hit it twice and now it says 29. What do I do? Well, I really wanted that one to be 28, so I'm going to go back here and put a 28 in there. And I don't need to renumber. I've got a 28 now. I'm going to click on this guy and now he's 28. 29, and 30. So I've got them all right, and I'm done. Now I need to recreate the animation equations. I'm going to create measured equations by assigning DOS. And again, it's saying you got things selected here. Do you want them unselected? Yes. There's 30 equations. Now let's start the animation. And let me arrange for animation. Again, I need to make this window a little smaller. It will maintain its size. And that's what I expect to see down here at these low frequencies. I go to here to this peak. There's the first torsion mode. There's the first bending mode. Those are my friends. Those are the ones I always look for when I set up a model and animate ODS data like this. Okay, we got a little time left. I think it's time for questions. So, Brian, do we have any questions?
We had a question kind of asking how to figure out where the measurements are assigned.
All right. The question was, how do we assign, or where do the measurements get assigned? We were looking at that. Let me go back into the I got to stop the animation. Let's go back into the structure window and open up the equation editor again. The equation editor, now I need to select a point. Let me just select them all. I'll just go, well, here's another way you can do it. If you hold down the control key, every time you click on a point, it will select it. So now I've got 4 of them selected. Now I can come over and look at their animation equations. These were the equations that the software created for those 4 points. Now because of the numbering, you can see that in each case, point number 1 in the spreadsheet was actually numbered as point number 1, and then 6 was numbered as 6, and so forth. Let me go this way and do point number 2. Okay, now you can see, well, they're all going to turn out because of the numbering scheme. The way the points were created when I created the model, they come out exactly the same. But this is a pretty simple case where measurement 1 gets assigned to point 1, measurement 2 to point 2, and so forth. But that's because my DOS in my data block over here matched up point for point because of my 1x or 1z, 2z, 3z. They matched up over here with the same numbering on my model and the same direction, the z direction. So I don't know whether that answers the question.
You might also show the measurement axis arrows display.
Okay. Brian is asking a different question. He wants me to display the actual directions of measurement on the model, and that's interpreting the equations. Let me make this large again so we can see that. And now I'll close the drawing assistant, or I mean the equation editor. I'm going to go again under that same menu though, and there's something down here that says show the measurement numbers. So that is going to put up, all right, well it's showing both the source and, let me turn off that, and I guess I need to click. It's not putting the measurement numbers up there.
I think you selected the wrong one. I think under draw or
display.
Or, no, the draw animation equations and show measured DOS.
Oh yeah. That one, yeah, the one that I executed down here is called select measurements. So all that's doing is selecting the measurements in the data block corresponding to a point that I select. This is the one that Brian was asking, show the measurements. Let me see if I can do that. And then I'll hold down the control key. Well, it's not showing anything.
Okay.
Let's see if that's actually selected. Show measured DOS.
It may not, you may have to turn off select measurements.
Oh, is that still on too?
Yeah.
Oh, it's not putting the measurement numbers up,
Okay.
but it is showing the direction of measurement for each one. There should be a label up here giving me the measurement numbers also, but that's not coming up right now. Anyway, you can see that the animation is going to give me the best evidence. Now here, you can see that I'm only animating a few points because I've got measurements still selected. So let me put things back over here and you can see why. This may happen to you also. I'm going to set things up here in the middle again. I've got only 5 measurements selected over here, so that's all I'm seeing on the animated picture. So I need to unselect them all if I want to see the entire shape, or if I just wanted to look. There's point number 1. Let's just say I wanted to look at the first 12 measurements. I'm holding down the Shift key now. Well, let's just go select them all very quickly here. So there are just the first 12 measurements being animated on the model. So this is selection works for animation as well as for drawing things and operating on your data and so forth. Any other questions?
Does the animation show the mode shape or the operating deflection shape?
this animation here is the operating deflection shape. The question is, are we looking at ODS or are we looking at mode shapes? We're looking at ODS here. We're looking at a deflection shape, and all we're getting is the values at the cursor position. Let me show you something else. I can use a different cursor here. I'll use a peak cursor, and this is very useful when I have data where the peaks are moving around. I'm going to turn the peak cursor on and put that over here. Now I'm animating from the peak value in each of my measurements. And as I scroll through here, you can see the little red dot. That's the data that's actually being used for animation. You can see down there, if it doesn't really find a peak, it'll just, this is near a node point, it just picks the one in the middle. And that's not going to change my shape a whole lot. There's a peak there. So the peak cursor, we had a question in the previous session, well, what if my peaks don't line up? This is how you would animate your data. And this is an ODS. This is not a mode shape. But at that frequency where the peak is, the ODS is being dominated by a mode. So if I drag this peak cursor over here, that ODS is being dominated by that mode. And so the ODS and the mode shape are essentially the same thing. Now this won't always occur. If I go back to the line cursor and just put the line cursor in my data, there's an ODS. That ODS is a combination of contributions from all of the surrounding modes. So the best assumption you can make when you're looking at ODS is that all the modes are being excited at all frequencies, but depending on their mode shapes, certain ones will dominate, and also depending on where the forces come into the structure. Now if I put this cursor right here in the middle, my best guess is that if I put force in at 0.1, which is my reference, remember let's go over here and put the point numbers back on. The way I can interpret this is if I had a motor running at this frequency, 384 hertz, we can convert that over to RPM if you like. If I had a motor running, sitting over here on the corner, let's say this is a floor in a building, and it was putting energy into the floor at 384 hertz, this is how that floor would respond. So the ODS is a function of the input, in this case the reference, and it depends on which resonances are being excited as to what that ODS is going to look like. When I get over here near a peak, now that ODS is being dominated by a resonance, and if I had a motor running over here in the corner of 0.1 at that frequency, this is what the ODS would look like. And it would look, because that mode is very close in frequency and its mode shape is being excited, it would dominate the ODS. No more questions. We're going to call it quits for today. Thank you for coming. As I said, next month we will do curve fitting, where we get into modal analysis. So you need that option in your software if you want to learn about that. And we'll look at all the different curve fitting techniques that are available when you purchase those options. The month after that, we'll probably do some work with STM and FEA and get into some more advanced capabilities of ME'scope. So thank you for coming. Have a good day.